Okay, this is example 3. We're going to go back to 2 tomorrow. Yesterday we did example 1 when it said find the exact value, and the angle that was given to you was not on the unit circle, right? So you had to find 2 angles that added or subtracted. Then we figured out which formula to use, that sort of a thing. If you guys go to example 3, you'll see this. You're going to have a question or 2 like this on your quiz, and it initially looks like a hard problem, but it's actually super duper easy. All right, in this case, you're going to need your formulas, which I gave you, and also the unit circle. So it's on your notes. You guys can scroll to it in a second. But the example here looks like this. And the question says, write as a single trig function and evaluate. So there's 2 parts to this question. You're going to write it as a single trig function, and then you're going to evaluate. You're going to tell me what the answer is. So when I look at this, the first thing you guys are going to do is you are going to determine which trig function they're talking about. Are they asking for sine, cosine, or tangent? How do you figure that out? You're going to match what they give you with one of the formulas. So right off the bat, this says sine, cosine, plus cosine, sine. What trig function is this definitely not? Definitely not tangent. Doesn't even look like the tangent formula. So let's go to the sines and cosines. Which formula in your formula sheet says sine, cosine, plus cosine, sine? So let's look up here. Sine, cosine, plus cosine, sine. So you're going to identify this and say this is sine of u plus v. Everybody understand that? This is how you would show me your work. It's u plus v. So u is the first angle and v is the second one, right? So I'm going to go one step further, and I'm going to combine this, write it as one trig function. This is 74 plus 16. Can anybody in here add 74 plus 16? Sine of 90. That is writing as one trig function. You guys have simplified. You've taken what the original formula was, and you smushed it together. You said, oh, what this question is really asking me is what is the sine of 90? Now, the second part of this question is to evaluate that. Sine is what value? It's the y value, right? So go on your unit circle, guys. What is the y value at 90 degrees? One good thing to do is say, okay, 90 degrees. What is the ordered pair at 90? 0, 1. This is my cosine. This is my sine. So what is the sine of 90? There's your complete answer. You're going backwards. These are really super simple questions because A, I'm giving you the formulas, B, I'm giving you the unit circle. So all you're doing is just working backwards. They're giving you the formula already filled in. You're just working backwards to figure out what angle they're talking about. Does that make sense? Yeah? All right, let's do the next one. What formula? First of all, I know right away it's not what? Not tangent, because it doesn't say tangent. But what formula says cosine, cosine, plus sine, sine? Cosine, cosine, plus sine, sine. It's the last one. It's cosine of what? U minus V. Remember, the cosine one is a little tricky, so just be careful. This is your U. This is your V. So I'm going to rewrite it as the cosine of 280 minus 40. Do you see the work that I'm showing? That's what I'm expecting to see on your quiz. What's 280 minus 40? So cosine of 240, that is the first part of your answer. That's writing as one singular trig function. So now you go to your unit circle and you say, okay, 240. What is the ordered pair at 240? Negative 1/2 and negative square root 3 over 2, right? So this is my cosine. This is my sine. So guys, what is the answer? When I evaluate cosine of 240, what is it? Negative 1/2. There's your complete answer. How do you guys feel? This is easy, right? Once I explained it, it's like, oh, it's not that bad. All right, so the last one. Obviously, what trig function are we talking about? Tangent. So which tangent is it? U plus V. Make sure, guys, take a second to just make sure that you pick the right one. The one that has a plus sign in the numerator and a minus sign in the denominator. So you're adding these two angles together. So tangent of what's 190 plus 125?
315.
Is it 315? Okay. There's the first part of your answer. First part of your answer says, here you go. You guys go ahead and you wrote it as one singular trig function. So now we have to identify what the tangent is. Well, at 315, guys, what is the ordered pair? Square root 2 over 2 and negative square root 2 over 2. Oh, this is easy. What's tangent? Y over x. So take the y value. Negative root 2 over 2 divided by positive root 2 over 2. What's your answer? What kind of 1? Negative 1. Perfect. How does that look? All right, I want you guys to, somebody pull up number 7 on your homework. Number 7. I want to go through number 7 with you because it's not a hard question, but we didn't really go over anything like that yesterday, so I want to make sure you guys understand. Let me see your number 7. All right, so Christine says sine of what? 405 degrees plus 1200. Okay. And then what's the second one say? All right. Everyone's number 7 is similar to this. Different numbers, but you're going to do it the same way. So I want you guys to write this down. These are two different questions. They're two completely different questions. The first one is similar to what we just did. What would we do with the 405 and the 1200 since it's in a parenthesis together? Add it. So this is sine of what's 405 plus 1200? 1605. Okay. Sine of 1605. Now, you guys are you're given a unit circle. So you're working between 0 and 360 degrees. Does anybody have any idea what quadrant or anything 1605 is? No. So how would we figure that out? Well, we're just going to keep subtracting circles. So 1605. I'm going to subtract. Go ahead and subtract 720. It's 2 circles, but to save us a little bit of time. What's 1605 minus 720? 885? You guys agree? Okay. Subtract another 2 circles. So minus 720. And I get what? Sine of 165. Is 165 between 0 and 360? Yes. Okay, so now we can figure this problem out. The first thing I'm going to do is look at the unit circle and say, oh, is 165 there? Is it? No, it's not. All right, 165 is not on my unit circle. So now we have to say, okay, I've got to find two angles that do what? Add or subtract to give me 165. Is there just one option? No, but go ahead and give me an option. What are two angles that add or subtract to give me 165? 135 plus 30. You guys agree? Okay. So what is the ordered pair at 135? Okay. And then what is the ordered pair at 30? Okay, now, according to what we did yesterday, guys, we're adding these two angles together, right? So does it matter if I make U 135 or U 30? No. Why does it not matter? Because you're adding. Okay, perfect. So now go to your chart with your formulas. They want the sine. So we're doing sine of U plus V, correct? So what does the formula tell us to do? Read it to me. Sine of U times cosine of V, okay, plus cosine of U times the sine of V. Everybody with me? You guys with me? Okay, what should I do to my two ordered pairs just to help me out a little bit? Let's label them. The first value, your x is your cosine. The second value is your sine, right? Help yourself out, guys. It's very helpful so you don't make a silly mistake. So now all we do is plug in. What is the sine of u? The first angle I made was u. What's the sine of it? Square root 2 over 2. Good. What is the cosine of v? Square root of 3 over 2. Plus, what is the cosine of u? Negative square root 2 over 2. And what is the sine of v? 1/2. Now, how do we simplify this? Numerator times numerator, denominator times denominator. What's the square root of, God bless you, square root of 2 times the square root of 3? Square root of 6. And what is 2 times 2? 4. Plus, what's negative root 2 times 1? Negative square root of 2. 2 times 2 is 4. Now, I want this written simplified, guys, so you can rewrite this as the square root of 6 minus the square root of 2 over 4. You cannot combine square root of 6 and square root, because this is 1 root 6 minus 1 root 2. You cannot say that this becomes a 3 and this becomes a 2, because one is inside of a radical and one is on the outside. Does everybody see that? Right? Yeah. Nope. So if you did you do it backwards?
No, I just didn't know.
Okay. Now, if you did it backwards, which is totally fine, you might have negative root 2 plus square root of 6. Is that the same thing? If I rewrote this as negative root 2 plus the square root of 6 over 4, is that the same? Yeah, absolutely. Depending upon, especially when you're adding, if you put u and v, when you're adding, it doesn't matter. If you use different than I did, if you use bigger numbers or something like that, it does not matter as long as it mathematically equals what you're looking for. Now let's look at the second one. How is this different? It says the sine of one plus the sine of the other. So when you have these split up like this, it's important to first figure out where you're even looking on the unit circle. Is 405 in between 0 and 360? Yes or no? No, so go ahead and subtract a circle here. If I subtract a circle, I have the sine of what? What's 405 minus 360? 45 degrees. Okay, great. Then I have plus, well, I don't know where 1200 is, so let's subtract 2 circles because I know it's bigger than 2. I got 480. Subtract another circle because it's still bigger. And I got 120, so sine of 120. Now, before you guys are like, okay, what formula do I use? I don't know what to do. Do you notice that you have 2 trig functions that are separate? Look and see. Is 45 degrees on the unit circle? Yeah, it is. What's the ordered pair at 45? Square root 2 over 2 and square root 2 over 2. All right. What is 120? It's on the unit circle, isn't it? So what is it? All right. That's good to know. Go ahead and label. What is the first is cosine, second is sine. First is cosine, second is sine. Can you guys look at this right now and tell me what the sine of 45 is, the exact value? Yep, it's the square root of 2 over 2. Plus, can you look and tell me what the exact value is, the sine of 120? The square root of 3 over 2. Can I simplify this at all? Why? Common denominator. Guys, when you're adding and subtracting fractions, do we multiply the denominators? No, they stay the same. So this just becomes the square root of 2 plus the square root of 3 over 2. It does not become over 4. Does that make sense? All right, hang on one second. All right, let's do, this is what everybody's number 8 looks like. Let me see yours. It's the sine of 3 pi over 4 plus 5 pi over 6. And then sine of 3 pi over 4 plus the sine of 3, right? Sure. All right, same exact question. What's the only thing that's different? It's in radians. So you guys can attack this one of 2 ways. You could, A, first just add these together. In order to add them together, what would you need to get? common denominator, all that stuff. Or what could we do? Can we convert them first? All right, let's go ahead and do that. Let's convert 3 pi over 4. What's 180 divided by 4? 45? Yeah? And then times 3? 135? Okay. And then I have 5 pi over 6. And let's convert that. So 6 goes into 180 30 times. So this becomes 150. And then what do I do with those two numbers? What's 135 plus 150? 285, okay? So what this question is actually asking me is what is the sine of 285? Well, check your unit circle. Is 285 on your unit circle? No. Do I have two numbers that I could add or subtract to give me 285?
225 and 60.
All right, I hear 225 plus 60. Does that work? Yes. Is that the only combination that works? No, but that's fine. So I'm going to take, actually, you know what? Let's change this to cosine, just because I want to use a different formula. Doesn't change. I just want to use a different formula. So what's the ordered pair at 225? Negative square root of 2 over 2, and square root of 2 over 2. Negative, okay. And then what is my 60?
1/2.
Square root of 3 over 2. Notice how we keep using the same numbers, guys. The only thing that's changing are the signs. We've got to be careful with that. So I'm going to say this is my u and this is my v. Do I have to make them u and v when she gets back? No, because we're adding. It doesn't matter. But let's look. So this is the cosine of u plus v. Read to me what that formula looks like. Cosine of u plus v. What does that formula look like? Cosine u times cosine of v minus, good, sine u times sine v. Very good. So let's go ahead and label. This is my cosine, this is my sine, this is my cosine, this is my sine. It's very helpful to do that. So now we just plug in. What is the cosine of u? Negative square root of 2 over 2 times the cosine of v, 1/2, minus the sine of u, negative root 2 over 2, and the sine of v, negative square root of 3 over 2. And now we simplify. This becomes negative root 2 over what? 4 minus negative root 6 over 4. And how do I write that prettier? Okay, so negative square root of 2 plus the square root of 6 over what? 4. Just like that. In this case, guys, you started off in radians, yeah? Do you have to convert back to radians? No, right? Because our answer right there is not in radians or degrees. That's just an exact answer. And what did I tell you? How could you check to see? If you hit cosine 285 and then evaluated that in your calculator, you'd get the same thing. I don't think you're going to be able to use calculators, though. All right, let's do this last one, and then I'll let you guys work. You should be able to get most, if not all, of your web assignment done tonight or today in class. Is 3 pi over 4 on the unit circle? It is? What is it? Say it again. Is 5 pi over 6 on the unit circle? What is it? What is it? 150? Okay. Now, let's go ahead and let's change this to cosine because I did in the last problem. Just to change it up a little bit. All right, what's the ordered pair at 135? We already did this. What's the ordered pair? Positive or negative? Thank you. And then 150, what is it? 1/2, okay. So again, cosine, sine, cosine, sine. In this case, guys, you're not pulling from the formula because you're not adding the two angles together and then finding the trig function. you're taking two independent angles and adding the cosines of them together. So this becomes negative root 2 over 2 plus what? Negative square root of 3 over 2. How can I write that as 1? Negative square root of 2 minus the square root of 3 over what number? 2. It is not 4. Yesterday, people kept making that mistake. 2 times 2 is 4. It is, but we're not multiplying here, we're adding. Does that make sense? Yes or no? We're good? Yeah.
Do we have to do it on both sides?
No, just put it right into a PDF and then you can submit it. Now, tomorrow's example, we're going to go back to example 2. We're taking a lot of stuff from chapter 4 and this stuff from chapter 5 and we're putting it all together in one problem. I will post this so you guys can watch it. Tomorrow we'll go over the last example. And then in class on Thursday, we'll review and we'll have our quiz on Friday. Sound good? All right.